In this video, we'll be building upon the previous autosizing videos, and we will be talking about the linear slot diffuser. When I was first tasked with creating this autosize family, um, it's tough to wrap your head around because there's so many elements. There's a neck size, there's an active length, an inactive length, the total track length, slot width, number of slots. So how do you go about autosizing? Basically, in order to accomplish this, we had to choose an input that we would control. So it would either be we were going to control number of slots and determine slot width, or we were going to determine slot width and auto-size the number of slots. So let's take a look at how this family works. So we have two different supply types and two different return types. We have an oval neck and a round neck. Once again, if Autodesk would allow me to manipulate the connector shape within the project, we could do this with one family, but right now we can't do that. So we have Flowbar and the ML slot diffusers from Titus. The ML slot diffusers obviously go up to quite a bit more slot quantity. The Flowbar is just 1 or 2 slot. So let's place one of these and look at the control parameters. So let's place this on a face. All right, so right now the diffuser has 0 CFM. So we have a couple, similar to the linear bar grill, we have a design airflow per length that we're designing to, and a design NC, and a design neck velocity. So now there's 3 design parameters that need to be controlled by the user to get a final selection. So let's give this some airflow and let's play around with a couple different numbers. Let's start off with 200 CFM. So the active slot length here, which is where the plenum is above this track, is based upon this design airflow per length. So we have 200 CFM, 200 divided by 50, you end up with a nominal plenum length of 4 feet. Now, just like the other air terminal families, we have sets of inputs that you can override. So these right here, these check boxes are essentially overrides. So if we check mark the 3 foot length, as you can see, our nominal plenum length will update. Okay, so right now we're at 4 feet. This is a very complicated formula now because we're looking for design airflow per length and the NC value similar to the linear bar grill. However, there's just a lot more conditions to check. So this family ended up having the longest formula in this release of the MPP. So a couple other things. So we have diffuser length and length input. This is the actual track. So if we set this to 8 feet, this is our actual total track length. So that's what diffuser length represents. And then the plenum length, of course, is the plenum that sits on top. Maybe we'll cut a section here so we can show So there, as you can see, we have the whole track and then the plenum on top. So for those that aren't aware, blank offs get installed on this section of the track, if so desired, and then this is considered the active length of the linear slot diffuser. So this is where the plenum is, which is typically insulated, and this is where the air is coming out. Air is not coming out from over here. So that's what the diffuser length is. If you keep this as 0 with no overrides in the input, this length will end up mimicking the nominal plenum length. So if we had a 3 foot, we have a 3 foot there. All right, so now the neck size, we have another set of inputs based upon the design neck velocity. So Titus in their literature, they say to size all the necks based upon 800 feet per minute. And that's what we've set as the default. So as you start increasing airflow, this neck size will inevitably change. So if we went to 300 CFM, so now we're up to a 10-inch neck. We also have some other issues going on right now with this particular family because we've exceeded the design airflow per length because this diffuser can only go up to 5 feet. So 300 divided by 50 is 6 feet. That doesn't work. So if you look at your linear slot sizing instructions, you'll see the available sizes, 2, 3, 4, 5 inch for the FL diffuser. And then we've got 1 to 2 slots. All right, so I guess one more thing is in regards to where this is being installed. Some of the diffuser families, we have different nested families from Titus based upon if it's surface mounted or mounted in a ceiling grid. This particular family, we don't have a separate nested family. However, though, let's go back to our 200 CFM. Okay, so if you look under construction here, the default is surface mount installation. You can uncheck that and you can choose lay-in. And as you can see, the frame installation type has updated. Nothing's changed visibly on the family. However, stuff in the schedule now will reflect the type of frame, the proper frame. And then with all the other grills as well, we've included dampers. So for a lay-in ceiling, it's not as critical because to have an inlet collar damper. However, above sheetrock ceilings, this inlet collar damper is very important because it allows you to balance the diffuser from below the ceiling. So now that's included there. Throw a tag on this. That's a funky damper tag. Okay. So there's the tags on the linear bar grill. All right, now let's talk about some design. And then we'll talk more a little bit more about these families. So I'm going to give you an idea of the zone that we're gonna work on right now. So my thermal zone diagram, I have all of my loads calculated. This is an exterior exposure. I like to split up each face of a building with different zones, if available, with the number of mechanical units that you have. So in this case, we have a south-facing zone. It's 2.9 tons. You know, the tag or the space, can convey the airflow that we need. So we're looking for 1660 CFM. Let's go back to the working view now. All right, so I've got, a long run of perimeter glazing here. And let's take a look at what this actually looks like. So there's multiple ways to provide a design for this. We could do a surface mounted linear bar grill up here and maybe angle the airflow down at 15 degrees. This little ledge isn't very appealing to using linear slot diffusers. However, for the sake of this being an auto-sizing linear slot diffuser demo, we're just going to plan on this type of design. So we're going to be throwing air at the window horizontally and to wash this face of glass. All right, so 1660 CFM is what we have. I'm going to get an idea of the length now that we're designing towards. So we can count up ceiling tiles, or we can just do a quick measurement here. All right, so it's about 34 feet, or 32 feet really of perimeter glazing. Here's what I'm going to do. I'm going to plan for providing 2 4-foot gaps in my linear track run, and the rest will all be designed based upon this airflow per length. So what that means is I have 32 feet. I'm going to subtract out 2 sections of 4 feet, which will just be blank offs. So that's 24 feet. And now we want 1660 CFM over 24 feet. So I'm going to come back to this diffuser here. We don't need the damper in this case. Okay. So we can type in a formula here. We can say equals 1660 divided by 24. Okay, so we've got a rounded down number here. I'm going to change this, I'm going to round this up to 70 now that I know what the value is. And now we want, I'll show you how this is going to work. So, okay, so I've got the first diffuser family set up. Let's go ahead and place this in this grid here. Now I'm going to copy this down. So let's copy the tag with it. Do multiple, constrain. All right, so there's all of our diffusers. We've got quite a bit more airflow than we need. That's because we have too many. So what I was planning on is having some blank off sections here. So some architects like just a continuous run. This isn't entirely needed. Actually, it just adds cost. So really, unless the architect just likes this, I guess that's what this would be for. Otherwise, save your project some money and just hit delete. So I'm going to change this diffuser to 0 CFM, and we're going to change this one to 0 CFM. Okay, so now, of course, our auto-sizing properties have changed the sizes of these. So we want to fix these at 4 feet. So we can select them, and we can say you're going to be 4 feet. And that's a little strange. Okay, so checking the 4-foot plenum does nothing in this case because the family is set up to use the minimum nominal plenum length if 0 CFM is entered. So if you go to your message center, you'll see edit airflow, minimum plenum length, and slot quantity is used. So in this case, though, we're not going to have a plenum. So what we're going to do is we're just going to turn the plenum off. So we're going to say include plenum. We're going to uncheck that. And now the diffuser length, which represents the track, is what will override. Okay. So I'm going to do the same to this one. And now we need to edit our slot quantity to match these other ones. So in that case, we're going to override, or we're going to enter the input value. So now, just like that, we have a linear slot diffuser system laid out. As you can see, we've got our calculated airflow covered. The rest is just making connections. So at this point, we could just select this duct. So I chose the oval neck, and one thing that we did is we rounded off. We made these nominal oval connection sizes. We got rid of a lot of the partial fractions that were there based upon the actual neck dimension. So let's draw some ducts. Go up to 11 feet. So there's our first connection. You know, a lot of times, before I even get to this point, I'll end up clicking on a nearby duct and editing the system, and then adding the diffusers that I want in that system. And I forgot, I'm in a design option with a sample project in this cloud model, so I can't show you that workflow at the moment, so I'm going to cancel that, and we'll just finish our connections. So we haven't gotten to it yet, but this is one of the Autosizing VAV boxes. You'll see as we continue to tie into this VAV box will continue to increase in size. Maybe I'll throw a tag on that so you can see what's going on. Let's look at heating capacity. Okay, so you get the idea. A couple more specifics about these linear slot diffusers. We haven't pulled up the performance table, so let's go and look at what's going on. Like with all the other diffusers, some have horizontal and vertical throw data. These FL diffusers do have had performance tables for that, so we were able to include that. And then going down to the data category, here's what we're looking up. Right now we've found two slots. So we'll put this over here. And now let's go back up to our constraints so we can see what's going on. Okay, so we're looking for 70 CFM per foot. We started off with a 1-inch size, so 70 CFM, and then the NC value right here is 33, so that does not satisfy the design NC, so we keep moving on to two slots, 70 CFM would have been this point, 17 is the NC value, so this is the data that should be reported. Let's go and take a look. All right, so we got NC of 17, and there's our throw values, 11, 17, and 25. 11, 17, and 25. All right, one more data point validated out of 5,000. Hope you guys enjoy.